So who are we? We are Natural Spaces Domes, which is owned and operated by Dennis Johnson and Tessa Hill. Located in North Branch, Minnesota, we have a complex of an office dome, 3 model dome homes, a screen porch dome, 2 workshop domes, and a furnished prototype of a mini dome, our option for small living spaces. We invite you to visit our complex for an in-person dome tour wearing a mask at this time. Natural Spaces Domes are easy to build, healthy living spaces, fantastically energy efficient while providing you the best housing value around. We started Dome Talk as a way to engage with the dome community, create a forum for all of your dome questions, whether they're Natural Spaces domes or not, and to provide a space for dome enthusiasts to connect with each other. That's why we want you to get involved in the chat. Now I'd like to introduce our hosts, Dennis Johnson and Derek Miller. Dennis is the dome guru and has decades of experience designing and fabricating domes. He knows what works and what doesn't, and has designed over 1,000 domes worldwide. His patented dome connector system is the best available, and he will help you at every step of your dome dream as a contractor, builder, designer, and dome owner. You're definitely going to want to talk to Dennis. Our project manager, Derek Miller, joined the NSD team a few years ago, bringing with him a lifetime of construction experience and handles a wide variety of responsibilities for us, from collaborating with Dennis on project management and client contact to working in the shops to refining building techniques. He's familiar with the dome process from the ground up. He's also our video guy, filming and designing the educational videos for virtual classes and tours. So I'll stop talking and let Dennis and Derek say hi.
Come here.
Hi.
It's my wife, Tessa, partner, and I'm Dennis.
And I'm the behind the scenes person.
Yeah. He has the hook.
When you're talking too much.
Yeah, right.
All right, have fun.
Hi, everybody. I'm Derek. Nice to see all of you again, or some of you, some new people and some repeats. So, and we've been getting a lot of questions, and as any of you have been here before, you know already that we'll try to do our best to get through them all, but I don't know if we're going to get through all of them all the time. We're getting a little backed up from previous ones. So our goal is if we can combine some of them too. So if we don't direct your question, or we don't ask about your question directly, we may be trying to combine it with another question. So, but we really want to encourage everybody too, just to jump in, especially if we're talking about your question, you have the opportunity to kind of clarify something for us, or if we're missing the point that you were asking, please feel free to jump in. We don't want it just to be Dennis and I talking. We want to get everybody involved. So don't hesitate, especially when we're talking about your question, to add to it if there's something that you can add to it. So, okay. And I guess we're probably ready to get going if we're ready for the first question then. I think we're starting out with an easy one, Dennis. So this one.
Yeah. And we have a really international audience tonight, folks. We have quite a few. Somebody from the UK is joining us, a few people from Canada, and one person that is living in Colombia and looking to build another home in southern Chile. So we've got a lot of international folks joining us tonight. So that's exciting. We're building our global dome community. I love it. All right. So first question tonight is coming from Jerry in Broomfield, Colorado. What are some best practices for interior finishing with hubs?
Okay. He's got one of our domes. He's been building himself, and he's probably to that stage. I think I'm going to guess that's where you're at, Jerry.
Absolutely.
Yeah. Good. I'm glad you're that far. Yeah.
Oh yeah, it's been a while.
The system that we have really evolved into what we created, which is a hub cap. And that's what we call this. It's 3/4 inch material. This is the same material as you see in the back over here. This is spruce. It's not pine, it's spruce. Very light colored wood. There's a rabbeted back cut on this. So you see on the inside, there's a smaller circle and there's a gap behind here. So this is the part you see. This is the little edge that you see, which is 3/8 of an inch. And this fits right here at the joint where all of these batten strips come together. Hopefully I'm pointing right there. You're seeing that, Derek?
Yeah, that looks good.
Good
That was
job.
impressive.
These are called batten strips that cover the joints in the panel. They are not the same material, but this is a pine material, clear pine. And it's called radiata pine. They're really similar in tone and color to the spruce paneling that we have. You can see they sort of blend out. But when we started out, we were miter cutting. That's very time consuming. So we created this as a way to put this on, and the batten strip slides behind it. You don't have to make a round cut or an angle cut. It's a square cut on the end. So it's really simple. You put this on that hub, put another one on the next hub right here, measure between the two, and add about 1/2 to 3/4 of an inch to that dimension. Straight cut. Slip it behind, put a couple of pin nails in it, you're done. It seals up the joint. I mean, for visually, it seals up the joint.
I'll be in touch about my order.
Sure. Yeah, we do sell these individually. You don't have to buy the battens from us. When you're buying a package from us, that's what usually comes with the whole thing, the batten strips and the hubcaps.
Thank you so much.
Sure.
Thank you. All right. Well, we're going to combine the second question with another question because it has to do with dealing with the elements in Texas. So we've got Deborah, and then I'm combining Shannon and Paul's question about building a dome in Texas. So Deborah's wondering about the fireproof resistant from forest fire, wind, hurricane, tornado, flood, sub-zero temperatures, termite and molds, humidity, basically East Texas environment. How do we combat Mother Nature with these domes?
I'll just-
Well, yeah, that one you got a lot of photos too, I think, didn't you, Dennis? So this is a good opportunity. We love these kind of questions, so.
She was probably talking about the last month in Texas with all of those issues.
Right. Yeah, so I'll let you grab this one, Dennis, because you kind of got a lot of personal experience with all these domes, so.
This is out in near San Diego in Alpine. The owner had 2 domes, they burned down. So he wanted a fireproof dome. Basically what we did, you can switch to the next slide. There's a surface material here that is called Supercrete. That's a brand name. There's other systems like it that it's sprayed on over the cement board that we put on, or that the builder put on over the 3/4 inch plywood. Flip to the next one. This is the inside of that dome. Still wood paneling, spruce wood paneling, using sheetrock, gypsum board on the extensions. So the inside isn't any different. Go one more slide. That shows you the cement board that was put on over the plywood before they sprayed on this finish material. And the seams are all mudded with grout. So it's a surface that is totally fireproof. Go back 2 slides. Try one more. Go back to the first one. You'll notice on the doorway on the right, that's not a shadow line. Well, it is a shadow line on that area over the door. It's slanted. So making this thing fireproof, part of it is not letting any burning embers get into the structure. So it's not vented. And creating a space that doesn't stop the wind from blowing the embers around, which a normal wide overhang would do. So it's a very short overhang. It's slanted. The other window on the left that's on there, you can't really see it because of the deep shadow, but it's the same design. So as part of it is the design of this thing. It's also the vegetation. Now flip forward past that one with the, one more. There you see that whole entire side of the hill burned. Took away quite a few houses along. This is an Alpine, east of San Diego. So there you see the compound right in the middle there. There's 4 domes joined together around a swimming pool. The swimming pool is part of it. There's some tanks in the back that store water. California requires that. 10,000 to 15,000 gallon storage tanks. And your swimming pool counts as part of that. The vegetation around this is what gives it now a true fireproofness, so that you don't have dry material that can burn. So that's all part of it. The landscaping is the other part of that. Let's go to the next group of questions. This is,
Oh, sorry. You know what you're talking about.
this is we call it the beach dome. We built this in 1998. This picture shows the construction of it. This is right on the Atlantic Ocean in North Carolina on Topsail Island. So this is talking about high winds, hurricanes, even tornadoes. And you can see, if you look closely at this, you'll see some straps, some stainless steel straps that are in the corners. Yeah, along there, between the windows from floor to floor, there are these strap ties. Everything is tied down, connected together. There are pilings that are holding up that second story roof, which isn't built yet. That piling is 24 feet. It goes all the way down and connects to another piling, which has been embedded into the sand dune. And actually there's a level that you're not seeing open underneath the house. That's for the tidal surge to go underneath the house. So this dome has a lot of things in combination here. Go on to the next slide. This is what I'll call the back side, the leeward side from the ocean looks like. This is cement board siding on here. It's 40, 50-year shingles. It's a high wind resistant shingle that's been used. When it was nailed on, it was nailed on with 6 or 8 6 or 8 nails per shingle, which gives it a wind speed rating in that range of 130 to 150 miles an hour. Go to the next one. This is the front facing the ocean. If you look at the right-hand side, you see the corner has been cut at 45 degrees on that 3-story extension. And that's from the structural engineer. I had a straight corner on there, and he said, don't do that. The wind comes around and it's going to create a lot of resistance in that corner trying to go around it. Cut it off at 45 degrees. The wind just rolls right around that side coming off the ocean. So the problem here that you have with the tidal surge, you can see goes underneath the pilings that are there. And those 8x8s, that's what they are holding up the roof. They're tied to the roof, tied to the second floor, tied to the first floor, and bolted with, I think they're 1.25-inch bolts to another 8x8, which is going down into the sand dune, 16 feet. There's a reason for it. Their code just requires some ridiculous thing about 5 feet above mean sea level or 8 feet down or vice versa. They had a hurricane go through here and wipe out quite a few houses that met that code. This dome from the ground to the top is between 50 to 52 feet. So it's quite tall. That upper right-hand window grouping is the master bedroom. When you're up in the master bedroom and it's windy and it's a storm, the structure actually moves. It's really strange. First couple of times it happened, I called my structural engineer out in California. And I said, this thing is kind of moving a little bit, not cracking. The sheetrock had never had a crack in it. And he said, yeah, so what's your point? I said, well, is it supposed to? He said, yeah, it's a wood structure. It's not a concrete steel structure that's solid. So the thing has some flexibility to it. This has been through quite a few hurricanes. Like I said, since '98. So we're talking 23 years on the coast. This dune walkover takes you right down to the beach. Go to the next sequence. You want to talk about snow, you want to talk about cold temperatures. We're dealing with Minnesota. We did have, what did it get down to? 26 below, 30 below. Here, where we are, northern Minnesota was our typical 40 below. The snow comes off the roof, piles up along the bottom. We have an entrance that takes care of that, which sheds the snow off of the entrance, so it's not blocking our entrance. But you can see this dome here is an R64 for the insulation rating. This is standard for us. We have domes that are R72, R80. So this takes care of this cold temperature. We don't have cold temperatures that are going to affect our dome. We keep this at 71 degrees inside all winter long. It's very comfortable, no cold drafts. On to the next one. That shows you some more. This has got 12 inches of snow sitting on those flat roofs, or I mean on the entry roofs. Continue to the next one.
I think that's the end of the sequence of pictures for that question.
Well, there's another part of that question. I think that we didn't have a slide for. What was the other part of the question? I'll look at my own.
Let's see, we had termite and mold protected from humidity.
Yeah. The humidity issue is really one where you're going to internally take care of that with the dehumidifiers. So, and mold is not an issue. If you're building a house in a warm climate zone, there are many ways to take care of that. Dehumidification through the air conditioning or a separate dehumidification system is what you need. You want to seal up the outside in that humid air down in Texas. I've been down there enough. I won't go back in August anymore. Except, yeah, this storm happened not in August, so gee. So it's the same with termites. We do rot-resistant lumber in the riser wall when it's severe termite. A lot of ways you're going to have the plumbing lines coming in and out, electrical lines coming in and out, and you seal around it with a copper mesh. So all of those issues that you talked about don't happen. And some of them don't happen in conventional houses if it's done right. But the other thing is the dome is going to have a lot more wind resistance because it blows around the dome. I say normally, the normal wind speed is 150 miles an hour. We can go up to 200 or more miles an hour. You design for the climate that you're in, design for the location that you're in. Let's go to the next question.
Okay, so we have two questions from David in Marblehead, Massachusetts. I'm going to give you the one because the second one is a little more in depth. So I'll give you the first one and then we'll do the second one. So the first question is, do you recommend for 100% ice and water shield under your roofing? And if so, do you apply it to the plywood before assembling the struts?
Yeah, this is the one, Dennis. I think you were thinking he might have been working with the panelized system, which is different than the system we use. So we use a strut system. I don't know if you got any photos of that, possibly, Carrie, of any dome framework, but yeah, so, oh, here we go. Okay. So if it's a panelized system, it's going to be assembled differently than ours. So in our system, you assemble the framework first, then you put the plywood on. And then at that point in time, you can put the underlayment on. And there's a lot of decision-making on what's the best choice for an underlayment. It's not always best to completely cover the outside of your dome in ice and water. Depends on what kind of insulation you're using in your climate zone. So there's a few factors in there, but a lot of people do it because it works in a lot of places. And it is a nice option if it is an option for you. So, well, here's one. Looks like Carrie found one that shows a little bit, but you can see where the framework goes up, and then we just put the plywood directly on the struts. once the skeleton of or the framework of the dome is erected. So yeah, I think in a panelized dome, you do it similar though. You would assemble the dome and then you do your underlayment after the dome was assembled. Some of those ice and water underlayments have a hard time spanning large gaps. So you just got to have, not too big a gap between your plywood sheets and you have no problem with it. And it is phenomenal for waterproofing. So if it is an option for you, if I had that option on my dome, I guess I would use it. So.
Okay.
Oh,
Sorry, Dennis.
I had somewhere the ice and water shield sample that I usually have here. It's disappeared. I'll blame it on my 4-year-old grandson. I don't know.
Yeah.
But the back has a release paper that you peel off, and the brand that we use is Grace. They changed their name to GCP, I think, Grace Products. Very aggressively sticky. If you happen to slip a little bit and you hit that, you took the release paper off and you hit another piece of it, that's it, it's stuck. If you happen to go along the ground, like you're peeling the paper off down below and it hits the pebbles or the dirt, it's on there. Throw it away, it's not gonna be good. It's very, very sticky.
Right.
Smooth it out.
It gives you good perspective about what flies feel like on fly paper. That stuff is very sticky.
Yeah. Yep.
All right. We ready for the second half? So the second half is that given that most conventional foundation walls join at 90 degrees, have you had any success recruiting manufacturers of precast foundation walls to produce wall sections tailored to some geometry? Anything you care to share about that?
There's a lot of things. The leading question here is that there are a lot of misconceptions about the dome. First of all, people think you have to have a curved surface. We don't really have any curved surfaces in the dome. They're straight segments of a sphere. So what you're going to see here is a series of different materials that can be used. There's brand names. So I think the first slide coming up is a superior wall. That's the brand name of this. And it's pre-manufactured, it's insulated, it's concrete. And we've got probably, I know, somewhere in the range of 10 to 15 domes that have this system. They actually make these panels with an angle on the end of the panel to match whatever the diameter of the dome is. So they're put up on a base. This is the base right here. There's no concrete footer. They want that to drain underneath that. This is P-rock, little 3/8 inch P-rock. You can go to the next slide. This is the outside. They do cover the joints with the same cement when they're done. It has insulation in it, and then you can add more insulation. That's a foam board that's built right into it. So what you end up with, go to the next slide. Here's the house on top of its foundation. This also happens to answer another question that we've got coming up later. If you look at these extensions coming out, that is an extension on the foundation. So we carry the load of those wing walls that come out, the canopies that come out that you see there. That load is carried right straight down into a foundation wing wall that sticks out from the normal round, I can't say round, segmented foundation. This, like I said, it's called Superior Walls. It's on your screen. This is another system. It's also an insulated panel, but it's studs. The other one is concrete. There are some studs in the other one. This has a similar situation where they have a certain level of insulation. They're putting it on a concrete footer. So they lay that footer out and then they place their walls and line those walls up perfectly. I mean, they're made for the particular dome they're going in. So they're not buy this 8-foot wall and cut it off. No, we give them the plan. They're making the wall to fit perfectly. Go to the next slide. Here's your outside, same thing. It's got, actually it has these strips every 24 inches, nailer strips that are there. So it's all in a matter of what you want to do on the outside of that. But you can see this goes around a very particular configuration matching the dome above it. Go to the next one. So this is what you're seeing here is still under construction, but it steps down on the one side, the gravel does, but the wall downstairs, as you saw, it's all the same all the way around. So the windows are actually framed into the wall sections. So you have to know what size the window is, what brand it is. There's a door on here. This is a 29-foot diameter sawtooth riser wall. The riser wall is that top portion, the top floor of this dome. I shouldn't say the top floor because there's a loft in here too. There's a walkout basement, a main floor, and a loft. Go to the next one. It's going to show you the finished product without the decks. There's decks actually on both sides that we're going to add on. If you look on the left, you see a door opening to nothing. So, and there's your snow again. This is down south of the border. It's south of Minnesota and west of Iowa, somewhere in there. They don't even have a town. There's no town near there. Continue on. This is insulated concrete forms. You're dealing with the hollow forms being poured with concrete. In most cases, that's 8 inches of concrete in the middle of this form. There's a couple dozen different brands out there. This particular brand is ARX, A-A-R-X, or ARXX, one or the other there. If I had my glasses on, I could maybe read what was on the print there. Go to the next one. Again, it shows you this configuration. It matches the upper floor. The configuration of this is built to match it. This material can be cut with a hot wire, so they can get the angles cut in those corners and just butt them together. And they put braces on them before they pour the concrete into it, but they are basically welded or glued together. It's a foam. You can get 2 inches or 4 inches of foam on the outside and it's usually 2.5 inches on both sides, and you can add more or get more on the outside. Continue on. This is the house, completed. It's a lower level lockout. That's a 40-foot diameter dome, and the other dome to the left is a garage. Go to the next slide. And you'll see that's the 36-foot diameter garage. Go to the next slide. That's a wood foundation system. You're dealing with, Derek, you can go into this if you want to take this.
Oh. Sure. Well, this is an option that we can offer for you. So as Dennis was showing, there's a lot of ways. It's really not unusual to have other angles other than 90 degrees, even on standard or somewhat custom conventional homes. They'll have some unique angles sometimes for the rooms and stuff. And so it's not a problem for any of your contractors to be able to produce the foundation you need. However, we also in-house will produce permanent wood foundations. So these can be pre-made and sent to you along with the dome. And the nice thing about these is they don't require a lot of heavy equipment. Essentially, they're assembled just like the rest of the dome. So the contractors that will be working on the dome for you can also do this work. You don't need to have a separate crew come in. And they're easy to insulate. They're made out of wood. And, they're they hold up for a really long time. I was a little leery of them when I first heard of the concept, but then the more research I've done, these sometimes outlast a lot of concrete foundations because they'll flex under different pressures like frost heaves and things instead of cracking. And because a little bit of the flexibility of the wood, it gives them a very long life. And of course, what you do when you build those is you do like a bituthane, which is similar to like an ice and water on the roof, but it's a little heavier material that goes under the grade, underground, and that kind of protects the wood even further. The wood does have a water protection treatment to it, but that's like another layer of protection. And then just basically proper drainage. And I mean, that's what you have almost in all your domes, don't you, Dennis? And they've all held up perfectly.
The first one was built in 1975, and it's not a problem at all. It's treated wood. It's just basically petrified wood, if you want to call it that. Bugs don't like it. You know, it's just totally impervious to things. It still is plywood as your outer layer, and that's why you need this layer of ice and water, really, which is bituthane, the brand name again for Grace. We also have a virtual dome school, and we go through all these things in the virtual dome school. We have samples of the ice and water shield and samples of the various waterproofing systems, but also of the foundation systems. We're dealing with a late winter storm here. I saw some lightning outside here.
I was just going to ask you, was that lightning? Wow. Okay.
And electricity went out.
He doesn't have the power.
Doesn't have any power. He's just texted that to Tessa. So.
Okay.
All right. Well, what we're saying here is
All right, so
not a problem. There are quite a few choices. Superior Wall is a really good wall, and Epitome was a new one that came along and said, we want to do this. And the owner said, yep, let's do it. I have had no problems at all with that one. I believe he's moved in now. So let's go on to the next part of that.
all right. So this question comes from Denise in Newburgh, Pennsylvania. Denise says, I just bought an original 1968 Bucky Fuller dome home with 10 skylights and a loft. It's time for a roof, and I'm planning to take out the skylights if they aren't a functional window. Is there any special venting suggestions or things I should look out for?
First
First
of
of
all,
all, go ahead, Dennis.
there's a slide coming up that I gave you on this one that actually is Bucky Fuller's dome.
Is he there? This guy asked the question. Is he there?
So the question I have is this the kind of dome that you have?
It is. That's like it's almost identical to every picture I've seen.
Wow.
This is made by the Pease Manufacturing Company, PEA.
Yes.
And they were the first ones with Bucky to come up with the standardized dome. I believe it's like a 39-foot diameter dome. Was one of their standard sizes. So where do you live? Where do you live? Where did you buy this?
I'm in Newburgh, Pennsylvania, and it's there's only been the one people who lived here, so I actually found old blueprints, all of this information that's from that company you just told me, the pictures with Bucky whatever his name was. But it seems like when they originally did the dome, they didn't have a good contractor. So the cedar shingles that they put on had a lot of water damage. They had to have it redone. There's been some damage. And although I was concerned when I bought the house, because I feel like there's a little bit of sagging, I don't know how it vents. And everybody's telling me about these cupolas or something you need. And I'm looking at roofing contractors right now, and I'm just getting really nervous, like what that's going to entail or what it's going to cost me.
Basically, you have a panelized dome system, and there are braces in the triangle. So to try to vent this dome within the dome shell, that's the big difference here. We're talking about two different air situations. The air within the dome shell itself, which is what we're showing you when we say here's a strut. This one is 18 inches wide. So our walls are 18 inches wide. In some cases we ventilate, in some cases we don't, that space. But you need to be concerned with your interior environment, the air that you breathe. You don't need a cupola to do what upper vent windows are going to do. So Velux, which is probably the #1 brand, I'm going to get some flack on that from the competitors probably, but Velux has actually solar powered venting skylights. Little solar panel on the bottom of it. I won't go into the details of it, but it's really good. It works, and you don't have to run electricity to it, and you can operate it with a keypad. It's also, they have an automated system that works so that it'll open and close by itself. There's a rain sensor on it. So if it starts to rain and it's open and you're not there, it closes. So the venting that you really want is that which is the air inside. You don't want this hot air in your dome, which is building up during the summertime, to go to the top of the dome and just sit there. You want to ventilate it out. You want to open those windows at night and get the cool air coming in. It drops, open up a window down below. The venting of the dome shell is a separate issue. And that would be one where you may not have vapor barrier in there, you might, but when it was built, probably did. I don't know what kind of insulation you have, but that's where we talk about,
Uh-oh, I think the storm's impacting Dennis.
You missed them. Yeah, I think where he was going with that is there's, if you wanted to ventilate the shell of the dome, generally you're going to need an airspace. Oh, you're back, Dennis. We lost you for a few seconds there, so I kind of jumped in. So I'll let you finish.
no, go ahead. I mean, you're talking the same thing.
Oh, okay. Yeah, so if you're, with the roofers, they're talking about ventilating the exterior of the dome, you need a little airspace in between the dome shell, which would be the plywood, I'll call that, and the insulation. However, I actually got, since Dennis always has props, I never do. I got to take advantage of this one here. I actually got the kind of the blueprints of his original dome system. And it was made with very thin, I believe it's just 2x4s, maybe 2x6s back in the day. So the odds are probably high that the shell itself is not insulated. It's probably, so you're just thinking of probably ventilating what you would gain from a cupola, for instance, which like Dennis said, just upper skylights that open essentially accomplish the same thing as a cupola without having to build that structure. So it's a more cost-effective way, I guess, to accomplish the same thing. And that way roofers install those all the time on conventional homes. It's not anything unique, where a cupola is a little bit different. So I think a cupola is a little bit more of an advanced installation, and it's going to be more costly than what you really need, because those skylights will accomplish the same exact goal. So, yeah.
I just asked real quick, because they gave me a quote for a solar powered attic fan, and I wasn't really sure if that made sense or if I should just get another window, because there's a bunch of skylights and there's only one functioning window. If maybe two of them would be functioning, it would help the house breathe a little bit better, but there's only one.
Yeah, look at the Velux catalog online. It's Velux USA.
Okay.
VEUX, Velux.
And that link is in the chat.
Thank you.
And like I said, they got a solar powered venting skylight, and it's really your solution, because then you don't have to run an electrical cable up to even low voltage. So, but you certainly can contact us more, especially when you got a roofer that says you must do this or you must do that. There are options to it.
Sign up for consultation.
Yeah, we have the consultation page that we have on our website. Go to the the menu bar and you'll see consultation. And I'm doing that right now with somebody who's got an older dome. They shingled wrong. They put ridge caps on all the joints, all the struts on the outside, all those lines of the triangles have ridge caps. That's a big, big no-no.
Well, that's another thing, Carrie, if you could maybe put a link in there for our roofing manual. So we do offer a manual. It's $30 that you could give to your roofers just so that they can have a reference on, how to do the job correctly. It's not that it's difficult, but there's a couple unique aspects to a dome that they may do wrong if they didn't know. It's probably the best $30 you can spend for just that peace of mind that it'll get done right. And just let them know that you want it done according to how the manual is set up, because most roofers will do it perfectly, but every once in a while you'll see a really nice house that was roofed wrong, and it's the worst thing to see because you just feel like, oh my gosh, all that work and they miss one detail along the way, and that one detail can be huge. So, okay.
All right. Thank you. It's a great question. We got lots of resources in the chat. I was busy, so make sure you check that chat for some of those links, everyone. All right, so this next question comes from Randy in North Andover, Massachusetts. Are shear or wing walls required where an opening is made by removing 3 triangles? If so, does the foundation follow the wing walls?
You got to.
Yeah, I think Dennis actually kind of. Yeah, I think that was shown a little bit on the foundation questions, but yeah, there's another good picture. And yeah, Dennis, you were basically saying that there does have to be a shear wall, and really the rule of thumb, I guess, or the standard practice is the height of your riser wall will dictate the minimum depth of the shear wall. So if you have a 28-inch high riser wall, your shear wall has to protrude out 28 inches from the dome. And there could be some small exceptions, not to get into those now, probably that'd be more of a one-on-one thing, but that's going to be kind of how that allows them to have the force of the dome wanting to push out, has something to support that. And I'll let you kind of jump into that, Dennis, because you probably know what photos Carrie's got and you can address it better maybe.
The next one too. What you're dealing with is there's at the bottom of the triangles, you have basically a tension line. So it's like taking your belt off. What happens? Well, things move out. So that's of concern. And these are some larger extensions, again, that have full foundation, frost footings. This one's in New York State. So it's got a frost footing that's 36 inches probably. So I can go to one more slide. I think there's one more on this sequence. Actually, no, that's for something else. So the answer to that real simple, yes, you need to carry these forces down to the foundation.
Okay.
Oops, I was muted. I was complimenting you and I was muted. So nice job. Great question. So this next question is from Frank in Prescott, Arizona. And Frank is wondering if there is a mini dome in his area that he can see.
Yeah, I'll grab that one.
You're going to grab. All I want to say is, if Frank is here, hello, Frank. I haven't seen you for a while, but Frank used to be a dealer of mine in Indianapolis many years ago. We won't tell him how many years ago. So yeah, I explained this. Derek is talking about a mini dome. So
yeah. Well, it's that's interesting, Frank. You'll have to maybe reach out to us and get a contact, because I just met with a gentleman here just south of the Phoenix metropolitan area in an area called Maricopa. It's a city, also the county, but ironically, Maricopa is in Pinal County. But anyway, there's a gentleman there that's looking to build a mini dome, and he's hoping to do it before it gets too hot in Arizona, which any of you that are familiar with that is only in a couple months. Generally by May, you're already really warm down here. So yeah, so maybe a short drive from Prescott to Maricopa, you might be able to have the opportunity to check it out. And that's another thing. He may be wanting to do some kind of a dome raising. So that's something, if you wanted to jump in and help kind of put it up and check it out that way. That's something we usually try to do with COVID. It's kind of it hasn't been something we've been doing as much as normal. It's kind of a customer on customer basis, but now that the shots are getting out there, maybe by May, it might be a good thing if you wanted to, go check it out at that time too. So.
Go to the next slide. This is this is in Nebraska. That's his solar panels. He's totally off grid. Go to the next slide. So this is our mini dome with a basement. So the top part from the deck up is the mini dome. We took 2/5 of the dome and sliced it vertically and removed it. That's what our mini dome is. This one is a 29-foot diameter. It's got 400 square feet on the main floor, another 150, 125, 150 on the upper floor. It's a bedroom. He turned the upper floor into an office. There's a series of slides here. Let's just flip through them. We don't have to spend a lot of time, but to show you the inside. That's the dining room, kitchen. This is the living room area. Small, a little bit of a spiral stair going upstairs. More of the kitchen. It's got a nice little kitchen. Not very little. You can see all the cabinetry he's got.
Yeah, he got a lot in that smaller dome. And he's got the basement in this particular dome as well, the walkout. So he's got a whole nother 400 square feet there. So
this is the lower level. So the master bedroom is on the lower level with a walkout with a big patio door. Go to the next one. There's the downstairs main master bath. There's a small half bath on the main floor. Go to the next one. That's the shower in the master bath downstairs.
for a small dome, it doesn't feel that short on space when you see those rooms though.
That's the loft. That's his office up there. There's a sitting area and there's this desk area over on the other side of that.
Yeah, that's pretty cool.
Maybe one more slide. I could be wrong.
That's it.
Okay, all right. So, yes, Frank, there is a dome that's coming near you shortly.
All
right.
right. So the next question is from Sue and Mark in Prior Lake, Minnesota, close to home. And they're asking about any insight on financing. Is it true you cannot do a conventional loan like a square house? And I do have a slide if you want me to put it up.
Sure. The answer is emphatically, you can get loans on a dome. You can get a mortgage. Being in Prior Lake, this is a survey we did. See the Wells Fargo? That's the loans on these domes. Where are they located? In Minnesota. All of these Wells Fargo domes, there's 30 of them with a Wells Fargo loan. You got to find the right loan officer that doesn't have preconceived ideas about it. But there are many banks. We've got a small, short list that we learned from our customers. This list that we have is about, I think it's 10 years old from the survey that we did. I'm not sure when that was exactly, but about 10 years ago. And we should probably do another survey where we take our list of domes, which they aren't all of our domes, but most of them are. We have 2,000 names on a list of dome owners, and we'll find out who's their mortgage. And the insurance issue to us is really not an insurance issue. We have a broker here in St. Paul that we're going to direct you to, and they happen to have their offices in one of our domes. Great convenient. Registered in 37 or 38 states. So they can write insurance for you. They're a broker, so they deal with all the companies that are out there. I think we have a current one is auto owners that we have. So, you know, it's all in finding that right person. It may take a little effort to it. You may get turned down for various reasons. Depends on your local bank, depends on the national bank. Your credit has everything to do with it. The property has everything to do with it. So how you're building, sometimes they don't want to loan to an owner builder, but there are other banks that will loan to an owner builder. So it shouldn't be an issue. You can certainly call us. We can talk to you about other lenders around. So.
Yeah.
Thank you so much. So our next question is from Olivia in Lauderdale Lakes, Florida. And she's wondering about willingness to help with a project, quotes and estimates. Also curious about pest control in a dome and temperature control or technology alerts or indicators and automatic technology that's available for the dome.
Yeah. Well, as far as willingness to help, normally, you know, again, COVID changes a little bit of things, but oftentimes we will go somewhere if you need help for the dome raising, or we can do it virtually. We're trying to do more virtual assistance now. And so that's something we can definitely do. We help out as much as we can through the whole process. In fact, I'm in Arizona now. And while I was here, I met up with the gentleman I was talking about earlier who's looking at the mini dome. And, you know, we try to check out their site and offer any advice and help out as much as we can. And that's really kind of part of it. We realize that there's not a lot of expertise in the dome housing industry, and there's nothing hard about building a dome, and any good contractor can do a great job, but we definitely want to be there to help answer any of those questions that may come up. And as far as a smart house, I think a lot of people feel that with the domes, there's you know, certain, you need like special HVAC systems perhaps, or plumbing might be installed differently than in a conventional home, or even electrical. But really it's exactly the same in a dome home as it is in any other house out there. Same HVAC systems, electrical, plumbing, and that goes with all the smart home systems as well. So you can definitely, anything you've seen for any other house, you're able to do, kind of like Denise's Bucky Fuller dome, where she may incorporate some smart skylights up above that will monitor air temperature and open when it needs ventilation and close if it rains. So these are things that are available to everybody, not specifically just to dome home owners. But if you see any of those kind of smart tools out there or services, they're all available for domes as well. So yeah, nothing unique about those, I guess. So
I mentioned the auto system that that Velux has that goes with their skylights. So that's a whole program they have, and it's a very inexpensive system comparatively. It's, I think, I want to say $200 or $300. I don't think it's more than $350 for a automation system which reads outside temperatures, weather, inside humidity levels, variety of things. And actually, most of these get trained to your habits. So if you don't have a standard habit, if you're vary quite a bit, it maybe can't catch up with you, but a lot of times you go to bed at a certain time, you get up at a certain time, and these systems learn that. And I mean, you can unprogram it, but that's what you're looking at. So,
yeah, make it easy on us.
all right.
All right, Carrie.
All right, so the next question, it comes from Paul in, oh goodness, Atascadero, California. I hope I said that right. Has anyone built a passive dome and or a net zero dome? They live in a high fire severity area, so they're also wondering about requirements for interior spaces, such as fire sprinklers and a 1 hour requirement for doors and wall surfaces.
It's not a problem. If the sprinkler system inside of a dome is much easier than a conventional house. We've got this open space that we have here. we've got a 49-foot diameter dome. That's what you're looking at here. It's half of a 49-foot diameter dome. The other half is a master bedroom and bath and a guest bed. So fire detection in here, the smoke goes to the very top of the dome fast. If you burn the toast, we got to worry about that smoke detector going off up at the top. So you get instant notification if you got some smoke issues. And in a dome, you don't crawl out because the smoke level is coming down on you. All that smoke goes to the top, and you have more than ample minutes, and a lot of minutes to get out of this house and do a 911 call. I missed part of that first part.
Net zero, I think. This was the, it is possible to do net zero dome.
Yes, it is. So that's where the slide comes in. I think that we showed before. We've also got a graph which shows you what we're talking about when we talk net zero housing. There's a HERS score. It's HERS, Home Energy Rating System. Believe it or not, some of the contractors wanted to change that. They didn't like HERS score. They wanted a HIS score. This standard house built to today's standard energy efficiency would have a 100 rating. Your older houses are going to be 150 or 200. And you're trying to get it down to a 0 rating. There's a note there that says 65 for this home. That's just an example. Our dome here was built 15 years ago. We had a HERS certification person come in here. The rating that we had was 57. At that time, 15 years ago, that was really good because people were even trying to get to 100. Nowadays, well, I shouldn't say nowadays, 5 years ago, we had a dome in New Hampshire. And there's a slide of that dome that ties into this question. Not that it's anything unusual, but that particular dome had a HERS score of 38. That's about as low as you can get, and before you have to add solar and or wind to get down to 0, meaning that you're going to be producing enough energy to offset what you use. So now you have a net zero ready, or I should say a net zero house with energy. It all relates to energy. It's all energy. The bulbs that you see here in this house are all LED. We got dimmer switches on it. It's a standard situation that you can do. But if you build a house to code, to this code, and you hit 100 and you think, oh, gee, I got a house, it's good, I'm right where it should be. No, that's the worst house you can build. You've probably heard me say it before, and I'll say it many more times. If you build to code, if that's all you can do, you didn't do a good job. We've stayed ahead of the code since we started building in the 70s. So that's where we're at. We talk R60s, R70s, we talk foam insulation. So all of this is all part of what we do. And this index is becoming very prevalent, the HERS score index. In fact, the new code requires a rating to be mounted next to your panel box or on your panel box door. Well, they don't want that on the door. They want it right next to the panel box. And it's supposed to stay there for the life of the house. So you know when you're buying a house, dome or otherwise, this is the energy rating that it got. Not everyone is going to do that, but a lot of builders have gone that way. Even the big builders, Pulte, Navy, and all these big time nationwide builders are doing something that is way beyond the minimum code. But we're doing even more and have been.
Cool.
All right.
Well, and with that, we are at 7 o'clock here. However, we did want to try to squeeze a couple more in for any of you that are interested in sticking around a little bit into, I guess I'll call it overtime here. We do this kind of normally because it is tough to get all these questions in, and we try to do as many as we can. So if you, we have a question for foam insulation and a question for earth sheltered domes. So for any of you that maybe want to stick around and hear those, we're going to try to get to those in the upcoming minutes, I guess. And then, so yeah, it's, and I know Tanner, yeah, with the electrical strikes, so I know Carrie's been kind of jumping around. So Carrie, if you want to jump into maybe the foam insulation question, everybody can hear that. And again, if you're in there and you want to jump into these questions as we ask them, please feel free. And we'll do the, we'd like to hear from you. So, all right, Carrie, sorry.
All right, that's okay. No, this question comes from Dave in Putnam, Connecticut. And Dave is asking, is spraying foam insulation open and or closed cell in a dome shell to fill the cavity a good idea? If not, what would be the best to achieve max insulation value?
We've got a picture on the screen here that shows spray foam. It is certainly an option. Spray foam ends up being more costly to install than fiberglass insulation. I shouldn't say it that way. There's a difference here because spray foam, they're going to come in and you're not doing the labor, and they're going to spray that foam in. In this case, this is a 49-foot diameter dome in central northern Minnesota. And I believe there is 7 inches, 8 inches of foam in this particular dome. In our dome here, we have an 18-inch wall with 16 inches of fiberglass. So we can do that and get an R value of 64. And here's the foam that when you get 6.25 per inch, or you can round it up often to 7. So if it is 7 inches, you'd have an R50, plus you get an R rating for the materials too. So you'll get up there. This is a tightly sealed house when you spray foam it. So is this one. The house that I showed you back there that had a HER score of 38 also had a rating for the air exchange that it has. And that's being governed by the code these days. It used to be, well, it used to be nothing. And then they lowered it and said no more than 3 air changes per hour. The dome in New Hampshire is 0.7. I believe that's what I read with him. So
Wow.
You need an air-to-air exchanger. We have one. It's upstairs. It draws fresh air from the outside and supplies each of the bedrooms with fresh air all winter long. Summertime, we don't really worry about it. So you're dealing with the stale air of the house being exhausted, and it's a 1-to-1 ratio, or you can actually make your house a more positive pressure or a negative pressure. You can do that with these systems. So you have options for your insulation. It isn't just one thing. You have to know the dew point. You have to know what the humidity is inside your house in the wintertime. You have to know what climate zone you're in. All of these factors are a part of it. I don't know if I'm gonna throw a curve at you. Well, go to the next slide on that. Shows you more of the same house. There's one more slide on it too. That also shows you up above in the cupola, there's a heavy foam, and it certainly looks like more than 7 or 8 inches up there for me. So there's climate zones, and we'll talk just a brief moment. I've got one here. I don't know if you have that slide you can pull up, and I don't have to show my paper version.
I think she does have it, Dennis. Might take her a second.
But sure, she can whip those things out.
Yeah. There we go.
I'm on it.
Good. So you can say there's 7 zones, but the reality is that black line that runs down between Montana and the Dakotas and cuts Texas in half. The right-hand side is moist climate. The left-hand side is dry climate. So that affects everything. Then you go out to that western states and you see marine, 4C, which is the coastal area, 3C, which is again coastal area. There's the marine climate that you got to be aware of. And there's a lot of moisture. That would be true down in Texas, but a southern part of Texas, down in Florida, the whole state of Florida. So we look at this, we analyze where you're building, we look at the various things that you want to do with that building. Cost is always a factor. How much do you want to spend? Are you an owner builder? Well, an owner builder can't come in and spray his own foam unless you buy the $4,000 or $5,000 spraying rig and then learn how to do it. But, or it might be more than that, but it's a situation where fiberglass may be your only option. So then what climate zone are you in? Are we saying that you decrease the insulation level further south? No. You need an R60. You're going to say in Texas, in Florida, in Arkansas, all over. The code minimum right now for about 2/3 of the country, zones 4, 5, 6, and 7, is an R49 in your roof. And the walls are an R21. We won't get into the politics of it, but there's an organization that has stopped the progress from saying, okay, you need a higher R value in your wall than 21. I know in Minnesota, when I walk outside and I'm walking outside of my wall through the door, it's 30 below. It's 30 below up over the roof. What's the difference in the insulation level? Why do I only need 21 on the wall? You lose heat through the assembly of the material that you've got. If it's windows, skylights, riser wall, a wall system, a roof system, cupola walls, they all have a different kind of an R value from the standpoint of heat loss because of their different thicknesses. But the reality is you need heavy insulation from the top all the way down to the bottom. That's what our dome does. It's going to give you, instead of a wall with an R21, it's going to give you a wall with an R60. Could be R80 if you wanted it. We've done domes with R70, R80. Our wall thickness can be anything you want, from just a 2x8 with foam insulation to 12 inches, 15 inches, 18 inches, 21 inches, 24 inches. So all of that comes into play with your climate zone and how you're going to build it and who's going to build it. How much money do you want to spend on it? It's hard to go back and add insulation. Put as much as you can afford into it now. The radiant floor heating system that we have, there's a test area in the middle, 16 square feet. There's 4 different kinds of insulation under this slab. We ended up doing 2 inches over the majority of it, but our test area after the fact, when we moved in, and I did, there's 2 temperature probes underneath 5 different kinds of insulation. 1 inch, 2 inch, 4 inch, and then 2 kinds of bubble wrap. Forget the bubble wrap. They are worse than putting nothing in, I think. Certainly you can see this, and it's on our Bear Creek Dome. You can look at it for yourself. But the 4 inch is what we would recommend as a minimum. I've got pictures of the domes in Denmark being built, and they're using 8 inch thick blocks of foam insulation below their slab when they're doing radiant floor heating. So they know something. Usually they get their stuff a better grade for doing this energy efficiency faster and more total than we do. So
that kind of leads a little bit almost into part of the next question anyway, as far as, the traditional advantages maybe with earth shelter can really kind of be made up with insulation, but I'll let you read that next one if you're all done with that last one anyway, Dennis. But I was just gonna kind of mention it does tie into the next one a little bit.
Yeah, it does. Can you do an earth sheltered dome? You first have to ask the question, why? Why are you doing an earth sheltered dome? Meaning, are you doing earth burned or earth covered? So you're going to have a lot of problems by doing an earth covered structure. The University of Minnesota in the 70s and 80s, that was the underground space center. Their offices were 3 floors down. They had temperature probes all around their facilities. There's a house that was built underground. There's a house that was built above ground and monitored. It's a whole program that the university did on their property. The house was called Ouroboros. It's a situation where it looks nice, put dirt on the top, grow grass, have the goats up there mowing your lawn on top of your house. We did earth burned homes, conventional, along with some of our domes back in the 80s. I used to have a catalog, I nicknamed it Earthitecture. And it really, what kind of ended that for me was when we started doing 15-inch, 18-inch, 21-inch thick walls, and the R value was so much more than you can get in an earth-covered structure. So it's your heat loss measurement. That's what you want to talk about. If that's your reason for it, no, earth sheltered, earth covered is going to be much harder to do. But if you're trying to do it for the looks of it, it's still going to be hard to do, but it may be your overriding reason for doing it. I don't really know who's the person that asked the question. Maybe I should say that. Are they there? Are they still here?
It's Lindsay from Greenville, Tennessee, and let me.
She on the list there? You can join in, but
I don't see her off the top of off the list, but
there's various nice looking houses that you may have seen that are earth covered. I had some friends back in the 80s, they built a 2-story earth covered house. Real nice design. That was from some people that were involved with the Underground Space Center at the university. So,
all right. Well, I think that's our last question then. And thank you so much, everyone. We had a couple questions left in the chat that we can address next time. And I just wanted to say thank you.
One more question too that Dennis and I were talking about, we're going to try to do next time in case that person is still waiting, is aging in a geodesic dome and how to accommodate as you grow older, how to make sure the dome's going to work right for you at that point. So that's another one I think we'll have for our next one. So I'll just throw that out there in case that person's like, what? when am I going to get the answer to that? So it'll be next one.
Yeah.
Okay. Well, great.
So the next dome tour, not dome tour, dome Zoom talk is going to be March 24th. But we'll also mention here, we have a virtual dome school coming up on May 1st and 2nd. We have another virtual dome tour coming up on May 18th, maybe 14th, maybe 16th.
Cool.
It's on our website on the cover page. We are scheduling a in-person dome school in September. We had it scheduled for August and we didn't feel comfortable with that, so we moved it back to mid-September. Again, it's listed on our homepage. And then another in-person dome tour here in the Minneapolis to North Branch, the metro area, and western Wisconsin sometimes. So we'll have a dome tour the first Saturday in October. It's either the second or the third, something like that. So that's what we plan for the rest of this year, along with this every 2-week dome Zoom talk that we really answer a lot of questions. They're different questions, and we are going to put these online as a question, along with the whole hour-long program that we have being put on there so that people can listen to the whole thing if they want. But the individual questions are being pulled out of that and listed individually. So you will have a video answer of what we said for those various questions.
All right.
Appreciate
All right.
everybody being with us and everyone that joined in. So
Yeah. Thank
All
you.
right.
Thank you to our international friends and everyone who sent questions in, and we will see you next time.
All right. Thank you, everybody. Have a good night.
Bye.
Take care and thank you.